So this is the types of energy and their equations part 1. So this is the second page in your packet. And the first thing that you're going to want to do when you start any energy problem like this is you're going to start by identifying where certain types of energy are zero. So for example, I'm going to start by labeling these circles over here. Just like there were pie charts for the energy skate park thing that we just did, we are going to have some pie charts to kind of help you guys out as well to identify what kinds of energy there are. So at the top, if we're talking about what type or types of energy there is at the top, we have all gravitational potential energy. This whole thing is gravitational potential energy. And the reason why it's all gravitational potential energy is mostly because your kinetic energy is zero. So all of it's gravitational potential energy. And the reason why our kinetic energy is zero is because the velocity is zero. So what you're going to do is anytime we identify that something is zero, like this kinetic energy being zero, we are going to put that in this table. So at the top, our kinetic energy is zero. And we know that because the velocity is zero. Then we have upper middle. So this is fairly far up in the air. So if I'm more than halfway up, am I going to have more gravitational potential energy or more kinetic energy? So I'm going to have more gravitational potential energy. So let's just guess. I'm going to say I've got this much gravitational potential energy because I'm more than halfway up. And then what else do I have? Kinetic. Good. All right. So my kinetic energy is small-ish. I'm not going very fast yet. But the rest of it is gravitational potential energy. So I have the energy stored up in gravitational potential energy. All right, and then I get closer to the ground. What's going to happen to my GPE? Is my gravitational potential energy going to get bigger or smaller as I get closer to the ground? Smaller, good. All right, so that means my gravitational potential energy is going to get smaller. So let's make it smaller. Let's say, oh, now I only have this much. And what does that mean for my kinetic energy? Bigger, good. All right, so this is your gravitational potential energy. It's getting smaller. And while that's happening, your kinetic energy is getting bigger. All right, and then at the bottom, remember that we're calling the bottom where you have a height of zero. So this is your height is equal to zero. And so at the bottom, what is my gravitational potential energy going to be? Zero, good, because gravitational potential energy is mass times g times height. And when my height is zero, whatever I multiply together, when I multiply any number times zero, I get zero. So if there's no gravitational potential energy, that means that everything left is going to be your kinetic. Now we found another zero. Ding, ding, ding. Exciting. Okay, so we got to make sure that we put this gravitational potential energy at the bottom is going to be zero. Okay, so we're remembering this is what's causing that to be zero. The next step in this, we haven't really talked about spring potential energy, but spring potential energy is the energy something has because of energy stored in a spring. Is there a spring involved when you drop something off of a building? No. So do we have any energy stored in a spring? No. So then all of these are just going to be zeros. There's no spring. We can't store energy in a spring if there is no spring. All right, and then the next part of this is we need to then figure out the GPE. So the way that I'm going to try to do some of these answer keys for these types of problems, besides what I've already done, is as I go through it, I'm going to do what I do first in red, then I'm going to do orange, then I'm going to do green, then I'll do blue, then I'll do purple. So I'm going to work my way through the colors so when you look at the answer key, you can see where I started. Otherwise, there's going to be a bajillion numbers and you don't know where to start. Look for the red first, and then that'll be your indication of where to start. So here, I'm going to start by finding my gravitational potential energy at the top, because I know gravitational potential energy is mgh. And what is the mass? 5. Okay, so that means my GPE is 5 times 9.8 times the height. And the height at the top was 12. And I get 588. And you can do exactly the same thing for the one below it. I'm going to find the gravitational potential energy for the upper middle. So again, GPE is m times g times h. In this case, though, mass is still 5, g is 9.8, and the height is 10. And so you get 490. It says that it's at a height of 10 meters. All right, so now here comes the easy part. We have figured out some stuff to the point that this row, we have all but one thing. So as soon as we have all but one thing, what we can do is we can figure out the missing box. So total energy is just if you add the 3 types of energy together, it's going to be equal to your total energy. Yeah, so 0 plus 588 plus 0 is 588. Now, if you remember, energy cannot be created or destroyed. We just did that. Okay, we're like, hey, the whole time the energy stays the same. So that means that regardless, these all have to have the same amount of energy. So that means all of these have 588. And then we're going to keep working our way backwards. All we have to do is find another row where we have everything but one thing, which is all of them, actually. So here I'm going to start with the next row. Okay, this row. So if I add the 3 types of energy together, this plus this equals that. Okay, so that means my kinetic energy, whatever that is, kinetic energy plus 490 plus 0 is equal to 588. Oh, well then I can find my kinetic energy, because I can just go, oh, minus 490 from both sides, and that means my kinetic energy is equal to 98. All right, so now I can stick that here. This is 98. Woo! Not hard. This one, we're also doing okay because we also have all but one number. So if I look at this box, I know that if I add the 3 energies together, I need to get my total again. All right, so let's do that. So we've got the first box is 200, plus my gravitational potential energy, no idea, plus 0 equals 588. All right, so that means if I subtract 200 from both sides, I get a GPE that is equal to 388. Yes! All right, so that goes here, 388. And then last but not least, the bottom row is this one. And in that row, I know that something plus 0 has to equal 588. Well, I don't know about you guys, but that means that this also needs to be 588. Yeah, because it's all kinetic. So if the total is 588, and all of it is kinetic, that means it must be 588. Now, the only thing left is it wants to know how high it was here. So at lower middle, what was the height? Well, I'm not told the exact height, but I just figured out right here that the GPE was 388. So I can find that height. So I know GPE is equal to my mass. What's the mass? 5? 5 times 9.8 times the height. And my GPE was 388. So 388 is equal to, what's 5 times 9.8 is 49 times height. Okay, so 388 divided by 49, and I get 7.92 is my height. At the bottom, it asks you a few questions, actually. So it says, how much gravitational potential energy is there at the top when the ball is first dropped? Okay, now that we've done the table, the questions are easy. So all we need to do is look at the table and go, how much gravitational potential energy is there at the top? Well, we figured that out. It was right here. It's 588. So right there, that's where we figured it out. What is the total energy of the ball? Well, we figured that out right here. That total energy was also 588. At a certain point called lower middle, there is 200 joules of kinetic energy. How much gravitational potential energy will there be at that moment? We said that was 388. And when there is 200 joules of kinetic energy, how fast will the ball be moving? Oh no! How are we going to figure that out? We have to look at the kinetic energy equation. Okay, so kinetic energy is equal to 1/2 times mass times velocity squared. All right, so our kinetic energy is 200. That's going to be equal to 1/2. My mass was 5 times v squared. Now, I'm going to give you guys a hint. I know that I can move the 1/2 over and then I can move the 5 over. My recommendation is to rewrite this as 200 is equal to 2.5 times v squared, and then divide by 2.5. The reason is then you are way less likely to make math mistakes. So I get 200 divided by 2.5 is 80. So 80 is equal to v squared. The opposite of square is square root. You square root both sides. And I end up with 8.94. And for part F, we already found the height at that point up here. We already found the height of 7.92 using gravitational potential energy equation and solving for height. So this is 7.92 meters. If you've got questions, let me know.